So our class has sections 5.1 and 5.5 combined. This is basically over systems and nonlinear systems. So we're going to go through and just solve a bunch of these. Most of this stuff should look pretty familiar, I think. It's not too bad. So for first example, we're going to look at 3x plus 2y equals 11 minus x plus y equals 3, and we want to solve this system by substitution. So what solving by substitution means is we're going to take either the top equation or the bottom equation. We're going to solve for one variable in terms of the other. So I'm going to take the bottom equation, add the x across, and the bottom equation will become y equals x plus 3. So I take one equation, solve it for a variable. I just said bottom equation, it's easiest to solve for y. Then the substitution part says, well, now that you know what y equals in terms of x, replace the y in the equation you didn't use with that value. So we get 3x plus 2 times, not y anymore. Y is x plus 3. That equals 11. Now we just need to solve this equation here for x. So we get, that. Subtract the 6 across. 3x plus 2x is 5x equals 11 minus 6 is 5. Divide the 5, so x is 1. So my x value of my system is 1. To get the y value, I plug the 1 in for the x over here in my equation. 1 plus 3 is 4. So x is 1, y is 4. So the ordered pair that solves my system is 1, 4. And that's how I solve things by substitution. So not too bad. Next, we're going to look at using elimination to solve a system. So we want to solve by elimination. So we got 3x minus 4y equals 1, and 2x plus 3y equals 12. So what we're going to do is we're going to need to multiply either one equation or both equations where we can make the numbers in front of one of the variables the same size but opposite signs. So I'm going to try to get rid of the x's. So I'm going to multiply the top equation by -2. That'll make a -6x. And I'm going to multiply the bottom equation by a +3. That'll make a +6x. So I'll get a -6x plus a 6x. And then I can go through and proceed with elimination. So if I multiply the whole top equation by -2, I get -6x. Negative times negative is positive. 2 times 4 is 8y equals -2. And I multiply the bottom equation by 3. So it'll be 6x plus 9y equals 3 times 12 is 36. So I add these together. The x's are eliminated because -6x plus 6x cancel. 8y's plus 9y's is 17y's, and then that equals 34. So I divide the 17. So y equals 2. All right, so for my solution, I know the y value is 2. I need to figure out the x value. There's two ways to do this. We can go back and we can eliminate the y's this time, or we can plug 2 into one of the equations and figure out the x. I think in this case it's going to be easier to replace the y. Let's say the bottom equation, replace the y with 2. And then just figure out what the x value is from that. So that'll be 2x plus 3 times 2 is 6 equals 12. Subtract the 6. 12 minus 6 is 6. So 2x is 6 divided by 2. X is 3. So my x value is 3, which means the solution to my equation is x value 3, y value 2. What this means is this ordered pair 3, 2. If I plug it in for the x's and y's, it'll make both equations true at the same time. So Okay, let's look at another couple types of these. So this time, let's say we get 3x minus 2y equals 4, and negative 6x plus 3y equals 7. Okay, sorry, hang on, let me see. Sorry, make that a 4y. Okay, let's try to solve this by elimination. I'm going to multiply the top by 2 so that I get a 6x. So we'll get 6x minus 4y equals 2 times 4 is 8. Then negative 6x plus 4y equals 7. I add these together, that's nothing, so I get 0 equals 15. So this is no solution, which you guys would say the solution set is empty. There is no solution set here because 0 is never 15. Okay, we're going to look at another case where, so this is called inconsistent. So this is an inconsistent system where there is no solution. We're going to look at another case here where we have infinitely many solutions. This is kind of another weird thing that can happen. So let's say we had 8x minus 2y equaled negative 4. And we have negative 4x plus y equals 2. So let's multiply the bottom by 2 this time. We're going to try to use elimination. We're going to make a negative 8 down there. So the top's 8x minus 2y equals negative 4. The bottom becomes negative 8x plus 2y equals 4. We add them together and we get 0 equals 0, which is always true. So you have infinitely many solutions. But so when you get infinitely many solutions, we have to go a little bit further. We have to do what's called choose an arbitrary variable, and then we have to put the other variable in terms of it. So I'm going to choose an arbitrary y, which means in my ordered pair, x comma y, the y value is just there as y. So if I'm choosing an arbitrary y, I need to solve one of the equations, let's say solve the bottom equation, for x, and get what is x in terms of y. So that way, if we know what y is, we can plug y into the equation and generate the x. So I'm trying to solve this for x, so let's see here. I would subtract the y across, and then I divide everybody by negative 4. And I'll get x is y over 4, because negative over negative is positive, minus 1/2. So I have infinitely many solutions, and they are all of the form, whatever the y value you choose for the ordered pair, you divide that y value by 4, subtract the half from it, and that tells you the corresponding x value that solves it. When you guys have these 2x2 systems and there's infinitely many solutions, choose the arbitrary variable. I think in our case, our homework, I think my math lab tells us like it's going to be an arbitrary y or whatever. And then you just solve for the other variable in terms of that variable. Okay, then the last type that you guys will see from these is the 3 systems. And just like with the 2 systems, if in the 3 systems you get 0 equals a non-zero number, or you get something that doesn't make sense like that, there's no solution, it's empty. And in the 3x3 systems, if you guys get 0 equals 0, choose an arbitrary y or x or z, and then solve the other 2 variables in terms of it, just the way we did here. So for these 3 systems, suppose we have 3x plus 9y plus 6z equals 3. We have 2x plus y minus z equals 2, and we have x plus y plus z equals 2. And we want to solve solve the system. There's a process. We're going to use kind of elimination style process for these. So first we're going to look and see which variable is most set up to eliminate with the least amount of work. And since we have a negative z and a positive z here, we're going to say, all right, this z's are what we're going to eliminate. So what I do is I write down a pair of the equation. So I'm going to use the second and third pair because they're already set up to eliminate the z's. And I eliminate the z's from that pair. And again, I'm eliminating z's because I looked through them all and decided that z looked like it was going to be the easiest to get rid of in the equations. So I choose a pair, I eliminate the z's. Z's cancel. So I get 3x plus 2y equals 4. Then what I have to do is I have to reset and get a second pairing of the equations and eliminate the z's again. So I'm going to use the top and the second equation. And the second equation's 2x plus y minus z equals 2. And in this one, I need to multiply the bottom row by 6 to make a negative 6z. That'll cancel with the positive 6z. So top is staying the same. Bottom gets multiplied by 6. Six times 2 is 12. Okay, so I get 15x plus 15y, the z's cancel, equals 15. And with this, I can actually reduce this a little bit further, and I can say, well, 15x plus 15y equals 15, divide them all by 15, and we get x plus y equals 1. So I have 3x plus 2y equals 4, and x plus y equals 1. Once I get there, I form a new system out of those two. And then I have to solve that new system. So I put those two together to form our new system. And then I got to solve this one. Let's use elimination one last time. Let's multiply the bottom row by negative 2. So we get the y's to cancel. So I'll get 3x plus 2y equals 4. Minus 2x minus 2y equals negative 2. Add them up. This is x, the y's cancel, equals 2. So, okay, in my final solution, which will be x comma y comma z, I know that x is 2. Now that I know that x is 2, I can plug x equals 2 back into one of these two equations and figure out y. I'm going to use this equation here. It seems easier. So I'll get 2 plus y equals 1. So we move the 2 across as a subtraction. So y equals 1 minus 2 is negative 1. Okay, so I've got x, I got y. Now I need to go back to one of my original 3 and find one that's easiest to work with. The bottom one looks like it's easiest. X plus y plus z equals 2. So we have x plus y plus z equals 2. X is really 2. Y is really negative 1. So we got 2 plus negative 1 plus z equals 2. 2 minus 1 is 1 plus z equals 2. Subtract the 1 across. Z equals 2 minus 1 is 1. So now we know our z value. And we have our problem solved. So basically, choose a variable to eliminate, choose a pairing, eliminate the variable, choose a second pairing, eliminate the same variable, simplify if you need to, form a new system out of those leftovers, eliminate in a new system to figure out a variable. Once you get that variable, use one of the two equations that formed the new system, use one of those two to generate the second variable. Once you know two of them, go back to the original equations. And now that you know two, plug them in and solve for the remaining, and that gets it. Okay, so that was 5.1, and now we're going to go on to the 5.5 types, which are nonlinear systems. So linear systems means that you have the form x plus y equals number, or x plus y plus z equals number. Now the nonlinear system types, you guys are going to see like x squareds and y squareds and stuff like that in them. But they work basically the same way. So let's say we got x squared minus y equals 4 and x plus y equals negative 2. This is already set up for elimination. If I just add these together, I get x squared plus x, which I can't combine that into anything nicer, so I'm just going to leave it as x squared plus x. Negative y plus y cancel, and I get 4 minus 2 is 2. So x squared plus x, subtract the 2 across, minus 2 is 0. Says, what happens here? We got a factor, I guess. Plus 2 minus 1 equals 0. X plus 2 says x is negative 2. And x minus 1 says x is positive 1. So when x is equal to negative 2, there's going to be a corresponding y value to that we need to find. So to get that, I'm going to plug that into the bottom equation here, and I'll get negative 2 plus y equals negative 2. If we add the 2 across, we'll get y is 0. So one of our ordered pairs is negative 2, 0. Then when x is 1, I plug it in. I'm going to use the bottom equation still. I get 1 plus y equals negative 2. So x is 1. I subtract 1 across. So negative 2 minus 1 says y is negative 3. So this time we got multiple solutions, which when you guys are dealing with the 5.1 linear systems, they'll generate either one solution, infinitely many solutions, or no solutions. But when you have two lines crossing, they can't cross like twice or three times. In these nonlinear systems, we can get things crossing 3 or 4 times. And so you just got to make sure that whatever x value, once you get your x values, whichever x value you're using, you keep the y value that x value generates. So like y equals 0 has to stay paired with the x it came from, which was negative 2. And y equals negative 3 has to stay paired with x equals 1. You can't do like x is negative 2 and then use the y negative 3. That doesn't work. So you just got to be a little careful with these about what x generates what y and keep them paired. So let's say we have a type where it's x squared minus y equals, whoops, sorry, we just did that one. So let's say we got x squared plus y squared equals 4, and 2x squared minus y squared equals 8. So this is all set up for elimination again. If we just add straight across, x squared plus 2x squareds is 3x squareds. Y squareds minus y squareds cancel. That equals 4 plus 8 is 12. We can divide the 3 across, so we get x squared is 4. So to get x by itself, we take plus minus square root of 4. So x is plus or minus 2. So we have x is positive 2. I'm going to use the top equation. So if I plug positive 2 into the top equation, I get 2 squared, which is 4. So I get 4 plus y squared equals 4. I subtract the 4 across. That says y squared is 0. And if you take plus or minus square root of 0 to get rid of the square, that is 0. So x value 2 pairs up with the y value 0. So we get x is 2, 0 back from that. Now we got to check what about when x is negative 2. Well, negative 2 squared is 4, so I get 4 plus y squared equals 4. That's the exact same starting point I just had in the previous equation. So I can see, since I just did identical work, y is going to equal 0 because the starting point's the same. So we already just solved that equation. It's right there. So this time I get negative 2 also pairs up with 0. And those are our solutions for that nonlinear system. Looks like we got about 2 more of these we're going to get through, and then we'll say that's good enough for those. So let's say we got x squared plus y squared equals 5. And we got 4x squared plus 3y squared equals 11. Okay, so I'm going to try to solve this one by elimination, and I want to get rid of the y's. So I'm going to multiply the top by negative 3. So if I multiply the top by negative 3, this will make negative 3x squareds minus 3y squareds equals negative 15. And down here I'll get 4x squareds plus 3y squareds equals 11. So I add these up. Negative 3x squareds plus 4x squareds is a single x squared. The y squareds cancel. Negative 15 plus 11 is negative 4. So x equals plus or minus square root of negative 4, which is an I, make it positive. Square root of 4 is 2. So this is plus or minus 2i this time. So when x is 2i, we need to figure out what y value pairs with that. So I'm going to plug that into the top equation. So I get 2i squared plus y squared equals 5. 2 squared is 4. If you guys remember, I squared is negative 1, so that's going to become 2i squared is negative 4, plus y squared equals 5, so I can add the 4 across. This will say y squared equals 9. To get rid of the square, take plus minus square root of 9, so I get plus minus 3. So the x value, positive 2i, generates two y values, positive 3 and negative 3. So we get 2i comma 3 for one solution from 2i, and we get 2i comma negative 3 for a second solution from there. So x equals 2i generates two solutions. Now we're going to say, what about x is negative 2i? So I plug negative 2i in. Negative 2 squared is 4. I squared is negative 1. Plus y squared equals 5. And that's exactly the same equation we had right here. We just solved that. So we just solved that, and we're going to get y equals plus minus 3. So negative 2i also generates two solutions. So we end up having 4 points where these intersections happen. 2i3, 2i negative 3, negative 2i3, and negative 2i negative 3. Okay, so that is how we solve those types. And then on to one last final type, and that'll do it. So we got 3x squared plus 2y squared equals 5. And we got x minus y equals negative 2. Now in this one, since the x isn't squared in the bottom and the y isn't squared in the bottom, elimination is not going to be a good choice to use for this one. So I'm going to try to solve this by substitution. I'm going to take the bottom equation and I'm going to solve it for x. So I'll get x is, we just add the y across. X is y minus 2. So that's from the bottom equation. So what I'm going to do is say, well, now that I know that x is y minus 2, I can replace the x in the top equation with a y minus 2. And hopefully good things happen. So when you guys square across a y minus 2 like that, we have to set up for FOIL. Since there's a 3 being multiplied to everything, whatever this FOIL becomes, it all is still multiplied by 3. So we have 3 times y squared minus 4y plus 4 plus 2y squared equals 5. So 3y squared minus 12y plus 12 plus 2y squared equals 5. Oh, good. Let's see. 3y squareds plus 2y squareds is 5y squareds minus 12y. And then the positive 5 here needs to subtract on over. 12 minus 5 is 7. Okay, so then we got to see, does this factor? Or can we quadratic formula this? Well, 5's really only 5 and 1. And 7's really only 1 and 7. And since 7 plus 5 makes 12, I feel like there's... See, outer pairs up with a 1, so that'll create a negative 5y. The inner becomes the 7. That'll make a negative 7y. So 5y squared minus 5y minus 7y makes negative 12y. Negative 7 times negative 1 is positive 7. Okay, so that works out. Then we just got to set each of these terms equal to 0. So y is 7/5, or y is 1. Okay, so we got 7/5 and 1 back for our y's. We're going to take those values and go back up to this equation, and we're going to figure out the x's that correspond to those y's from this equation. So we got 7/5. Let's do that one first. So y is 7/5. So x is 7/5 minus 2. To get 2 in terms of fifths, I multiply it by 5 and divide it by 5. So this is 7/5 minus 10/5. 7/5 minus 10/5 is negative 3/5. So one of my ordered pairs is negative 3/5, comma 7/5. Then the other y value was, what if y equals 1? Okay, so that one we can just kind of look at. If y is 1, and you guys put 1 in here, so if we put 1 in for y, 1 minus 2 is negative 1, so x is negative 1. And that wraps that up. Alrighty, so we are done with that. That's basically it for this week. So we'll stop there.